Oh. Ah, interesting. Windows. Okay. Okay. Okay, I believe you can see my screen, right?
Yes, doctor.
Yes, okay, thank you. Right, okay, so today will be an introduction class. As you have been experiencing now, you would have realized this big data, data science, statistics has been the inward. Everyone talks about it, and everyone is expected to know how to deal with the data. What do you do with the data? How to play around with the data. So everyone is expected to have some sort of knowledge. And actually, if you know the history of it, the computer science people actually uses a lot of data works. They are the one do this machine learning stuffs, these automations. They do a lot of they work with a lot of these things. But times have changed so much that everyone now have to have some sort of knowledge about data and how to use the data to give us a valuable input. That's why even our class, it just used to be an introduction to statistics. So it was just meant to introduce students about basic statistics, which you learned in schools, and a little bit more of it on how we use it, a little bit more. But now we have decided to change it to applied statistics. Of course, in the last three years, we changed it to applied statistics because we believe it's important for our chemical engineers to know how these statistics can be applied into our chemical engineering problems to derive a solution. Okay, so as you would have known so far, the statistics would have been you dealing with data and then trying to get your mean, average. So you have mean, you have average. So you have to know when to use the mean, when to use average. Okay, both means the same, but you use it for different type of data. Okay, and then when do you find you find variance, you find standard deviations. So these are the simple maths, simple, we call this descriptive statistics. These are simple statistics you would have applied. Okay, but in our course we will go a little deeper on how we make decisions from the data that we have. Okay, so that's why I put in this picture. So if data is like a criminal, so if you interrogate it hard enough, it will tell you whatever you want to hear. Okay, so it depends on how you play around with the data. It can give you different insights to it. So sometimes you can make the insights favorable to you. You can just select the data that will give you your desired output. Okay, that means that can be a bit biased, misusing your data, or the data can give you some hidden informations that you were not aware of, that you can't actually see it with your bare eyes. I mean, you can't see it with the problems that you look at, but when you look into the data, then you see, oh, there is a relation, there's an interrelation, and then there's also a secondary issue that is causing this primary issue. Okay, so that's the whole idea, and that's how we are going to look into this whole course. Okay, so we are always going to interrogate the data, play around with the data to give us information. Okay, not just maths, not just you pressing the calculator finding the output, but you interpreting what the output means to us to address that particular problem statement. Okay, so that's actually a summary of what the course is all about. Okay. Okay, so this is your learning outcome. So the first few weeks we'll be looking at estimating the characteristics of population via statistical inferences. Okay, so there are few, there's just two. We have descriptive and inferential statistics. So you're expected to know how to estimate the characteristics. Okay, these are the basic calculations of statistics, and you give an idea of what the characteristics means. And then we are to perform hypothesis testing. That means you think A is causing B. Somewhat with the relation with what you see that is happening, you think A is causing B, but you want to test if your data is supporting your claims. Is your hypothesis correct? Is A really causing B? And once you get that output, maybe it is causing B, you also need to know the confidence intervals, which means how confident are we of our output. So we'll be learning confidence intervals. Okay, and then we'll be learning about populations, means, variance, or proportions. And then you have third one will be to propose experimental designs. Okay, this experimental designs, this is actually a different site. This is completely new for you, where we will be using some statistical tools to design experiment. A lot of your FYP students, FYP seniors, a lot of your seniors in year 4 who does FYP and do experimental work, they use these experimental designs. Okay, so it's a software which I will also introduce to you. But before we learn the software, we will learn the basics of it, on what it means and how we design our experiment. Okay, so this one, the use of it is, instead of you doing 100 experiments to find a relationship, you probably just have to do 20 experiments to get the relationship. So we will do that in our third learning outcome. And the fourth one is how would you analyze your experimental output? So we will be using ANOVA. So you'll be learning ANOVA, one way and two ways. We call it, it's an analysis of variance. That's ANOVA. From the experimental design, we analyze using ANOVA method, and we find the relationship between parameters. So this is actually one branch of statistics. Actually, statistics is also fundamentals of machine learning, fundamentals of artificial intelligence. We can also use these statistical outputs to deploy machine learning. Okay, but with these 2 hours, we will not have time for machine learning. So we will, in this part, we are going to look into experimental analysis and how we are going to use statistics to help us in that. So that's the whole picture that you're going to have throughout this the next 12 weeks. Okay. Okay, so for this introduction week, today is going to be a little bit free and easy. So I'm just going to introduce you to statistics and why it's important, and then focusing it on experiments and optimization of your experimental work. And then what is the meaning of population and samples? What are the parameters that are important in statistics, and what do we mean by mathematical and statistical modeling? So today is a little bit of just exposures and understanding certain terms. Okay, so tomorrow, next week, we'll move into detailed calculations.
Sorry, Doctor.
Yes.
I believe that some of our batchmates, they can't join the teams because their requests are not approved yet.
Yes, I was just about to escape this screen and
Right.
yeah, thank you for the heads up.
Right. Thank you, Doctor.
Yeah, okay. So I'm accepting them. Yeah, so every few slides I will go back to have a look just in case. So I've accepted some. So I've already got 60 by now, so it should be everyone in. But if there's still some of you pending, please interrupt me. Yeah, thank you. Let me just check if anyone. Who's this? Aaron Chen. Aaron Chen, are you in? I was having trouble with Teams. There was error. Trying to say no. Aaron Chan, are you in? Not yet. Who's PM Classy? Are you in? Okay. Okay. Shengji? Are you in, Shengji? Alamak.
Hello, doctor.
Are you in? Who's this?
I'm Gary, and Sunji is my roommate, but he cannot join. Although he sent the request, but I'm not so sure why it didn't appear in the pending request there. So
I can't see.
he is actually watching with me.
Okay. All right. Okay. Then you just put your name into attendance later.
Okay.
I'll just edit in. Okay. See, I'm showing you my screen so you can see that I cannot see your request, isn't it? If you can try again. So Shengji sorted. Siapa lagi? Who's this? Aaron Chen. Aaron Chen. Aaron Chen, are you in? Okay. Okay, Shinji. Okay, I'm aware. Request sent. What's this? Shinji request sent. But then Shinji, I don't get your request. I believe you must you use your Siswa mail or no, you must use your UM365, right?
Yeah.
Okay, let me add Shinji's email. Can you give me your email address? Shinji?
Okay, 我可以打在你 chat box 吗？Doctor.
Type your email address or you just give it to me. I try add. Three of you are not able to be in. Now I don't know who's this PM class C. Yes, doctor, but I don't see any ongoing meetings. They're all ended for me. Alamak. Okay, Shenji, give me your email address. I will add you in here.
Doctor. This is Sunji's Siswa mail.
Where?
Yeah, he typed using my account.
Sudah masuk. Where? Yeah, am I watching? Have you given it to me? I can't see. Okay. I'll try to edit in. Address. Okay. Right, I've added you in and see if you can come in now. Let me add 2 more of your friends. Please give me some time. Give me your email address. Shenji, give it a try and let me know if you're in. What's this PM Classy? PM Classy. GKHLASSY. Okay, he entered. Aaron Chen is in. Okay, just one more person. So I don't know who's this PM Classy. If you're in, let
Doctor,
me.
Our PM class is actually E-class and he's already in the meeting.
Ah, okay. Then why is he not giving me a reply? Thank you. Thank you for letting me know. Okay, Shengji is in. Okay. Someone doesn't see ongoing meeting, they should go to week 2 in the Teams. Okay. Thank you. Thank you. So I thought I gave you the week 2 link. Okay, never mind. Let's sort it together. So I think now all of you are in. Yeah, because I have 61 member. Someone came in with, I have someone additional. Okay, I should have 60, but anyway. Okay. Anyway, just give me a heads up if someone is still out there. Sorry, doctor. Someone told me you're looking for. I was having my breakfast. Yeah, I was looking for you. Okay. So now I just wanted to know if you're around. All right. Okay. Maybe one day we should start by having tea. We should start the morning at 9 o'clock and we all have the breakfast together. And then we start at 9:15. Yeah, being too ambitious now. Okay, let me get back to the slides. Okay. Feel free to have your breakfast, eat while you're listening to me, so don't worry, be at home, okay? Right, so introduction to statistics of engineering. So for us to know, for you, you would have already been exposed to this even from your primary school, where in science, we collect data, then we analyze what we have collected, and then we present the data systematically. So all these three are very important. Okay, so this is what you learned in school all this while. This is how it is. You collect the data in experiment, you do experiment, you collect the data, then you analyze, you draw a graph, and you analyze first. You analyze whether you analyze what you have got. Okay, that means like for example, if you put in solution A into solution B, then something happens, then you analyze what happens, and then you have a data, you have a value that you get, and then you draw a graph, and then you submit your experimental report. So that's how it has been. But now we add a little bit more. We collect data, we before we analyze, we process the data. We call it data cleaning. We process the data a little bit, then we summarize the data. Okay, after we do the cleaning, after we do the processing, we summarize what we have got. That means this time in our data analysis, data processing, we will have how many data that cannot be used. Okay, so total you collected about 100. From there, 20 cannot be used because some information doesn't exist. So you can only use 80 more informations. And from that 80, you find the mean value, you find the variation. Okay, so that's your pre-processing. And then you do summary, and then you present your data, and then you start analyzing your data. You rearrange your data, you put it into different columns, you find what is the pattern that is in the data, because some data you cannot just put a straight line into it. Maybe it's a quadratic, so you have to put a curve. You have to have a sigmoidal graph. Maybe it's a cubic, so cubic will have a exponential graph. So you will have different uh, information that is hiding in your data. So you analyze it. Then once you get your pattern, you interpret the data for your study. Start interpreting. Oh, that means this relationship is not linear. This relationship is quadratic. That means I need to have an impact of b square to give me an output of A. It is not A is equals to B, A is equals to MB. No, it's not A equals to, Y is equals to MX plus C. Is your linear relationship. But if Y is equals to MX plus M1x1 plus M2x square, that is a quadratic relationship. So you start interpreting how each parameter is affecting one another. And then you describe a given problem. So if I'm having this problem, so if only my B solution is B square, that means double the amount, I have a A problem. So if I can reduce the B, I won't have the A problem. So you describe the problem, you come up with a solution. Okay, so statistic is the art of learning from the data. So data is just number. They give you table, they just give you a data. But what is coming out of it is for you to use your skills. So it is a skill for you to develop. And for you being the undergraduate in this era, knowing data and trying to learn from the data is very, very important. A lot of your seniors are actually working with data. A lot of seniors who just graduated and went off, they're working with data, computers, visual basic, machine learning, controls. So they're all looking into data and how to make improvement from data. Okay, so this is an important skill for you to pick up. So statistic is a study of population. So population means it's the whole set of people. So if I'm talking about frogs, so I'm talking about all the frogs. But if I'm only talking about the specific family of frog, specific species, family is memang frog, so the species, then I'm talking about sample. That's the smaller, the subset of a big population is the sample. So statistics is for most of the time is for us to study the big population. We want to know what is the characteristics of that big population, be it plants, be it animals, be it human, can be anything. Okay, and the study of variation, just like our COVID. See how it's changing. It just started off with COVID. Now we have alpha, beta, gamma, delta, all sorts of things. And then the beta also got beta 1, beta 2. Okay, and then as we go, you see, we also have stages of people. Last time, either you're infected or not infected. But now you're infected. Are you in stage 1, stage 2, 3, 4, and 5? Okay. And then it's also the study of methods of reduction of data. So sometimes you have too many data, okay, especially if you see in industries, there's so many big machineries, all parts have got sensors. It is taking pH, temperature, feed in, feed out. There's so many information that is being collected. But what does the information tells us? What does it gives us? Maybe there's 10 different parameters that is being collected from that equipment, but only 3 parameters is really affecting the equipment. Okay, so in statistics, we will also learn that. We will also learn the components that is important in our study, that is important for the problem that we are looking at. Okay, so we also have a term for it. We also have this reduction method. For you, I will show you how to know which are important parameters. But there's also a further study which we call principal component analysis. Okay, and there's also branches to that principal component analysis where when you give it 10 data, it will find the best data that explains a particular problem. So from 10 parameter, you probably just reduce down to 2. And that 2 parameter can actually tell you how our output is being affected. Okay, so these are importance of statistics. Okay, so there's so I've already explained this importance while I give you this example, this definition. Okay, so it simplifies the mess of data. So when you have a lot of data, you can actually reduce it to only this 2 component data, because only these 2 component is representing you the output. So you don't have to look into all the 10. Okay, so it simplifies the mess of data. And then it gives you the information, and then it helps you to give a reliable and objective decision making. So for example, if I have 5 products that I want to sell, but now my resources are very little and I have to find out which one should I produce more so that I can get more return and build my finance. So from my 5 product, if I do an analysis which product is fast moving, is a customer favorite, and then which are the places which I am selling this product that is getting the people's attention, so I can make a good decision. on which product to sell more, to target for higher marketing in order to make more income. Okay, so it gives us this data collection and analyzing helps us to make decision. Okay, and it presents facts in a precise and definite form. Okay, so that means your data, your information, your data, you get exact precise numbers. It can give you numbers. If I put in 50 here, it will sell out in 10.5 days. In 10 days, 2 hours and 3 minutes, it will sell out. It can give you precise information, but your information is only as good as your data is. Okay, whatever information that it gives you is only from the data. So that's why the data is important. Okay, and that is in fact the limitation of statistics. If I give you this data and say you do this analysis, and if only use, if your data is weak, poor, or if your data is bad, then our facts and information are also as bad as the data. It may not be representative. But if I give you a very good data, whatever you come up with it is also a very good information. Okay, that's statistics. That's data. Okay, that's what people are feeding into us as well. So that's why we don't buy everything that is being fed into us. We have to know the legitimacy of the data that is being used to give us that information to us. There's a lot of infographics around, right? There's a lot of things that we see around. So there are a lot of things that you are actually absorbing. So your critical mind should always think, how reliable is this information? So this is very, very important for our undergraduates, which we lack. And thankfully for our our students, you are being trained to think critically. You do a lot of presentations, you are being asked a lot of questions along the way. This is what I have seen in the last couple of years. The students actually evolve. So keep feeding your critical mind. Get your mind to think and ask questions about the data that is being fed to you. Okay, the infographics can be beautiful, but are they reliable? And always have that questioning mind. Okay, and of course it facilitates comparisons. You can compare between how one state is performing in comparison to other state, and how is the weather in different places. Okay, and it facilitates predictions. Yeah, this is our machine learning part. Okay, so with whatever that is happening now, and with whatever data we have, we call it historical data. So we use this historical data, we train our machine learning algorithms, and then we can actually predict if let's say I can predict haze. Okay, that's one of my research work. So I can actually predict haze using the environmental parameters. There are certain parameters that's being collected by our quality alarm, sorry, not quality alarm, air quality department of environment, meteorological Department of Environment. They have got meteorological unit, and they collect information, daily information about our air quality. So from the air quality, we can study the changes, and with the changes, we can actually predict haze. We can predict PM 2.5. So we can make predictions. And not just that. So I can bring you back to processes, because in this study, we are going to look into process. We're going to look into experiments. We're going to start as small as experiment, how to optimize your experimental run. And then from there, how to make predictions. So if I put in A and B, I want a quality of C. So will I get the quality of C? If I will not get, what changes must I do to A and B in order to get the C? Okay, this is what statistics does. Okay, and it helps to formulation of suitable policies. Okay, this was actually, you would have been exposed to it during our COVID-19, where a lot of information were collected, a lot of survey was done to see how people are suffering, how we can help people, and then what kind of first aid what kind of assistance that can be given, like how they used to give this BPH, is it the bantuan? BPH, I can't remember. Yeah, the bantuan, how much we should give, when we should give. So these things during the COVID conditions, and then they also came up with a lot of policies, a lot of changes based on the conditions and the needs of the people. Okay, so literally every part of our life has got data, especially now with your My Sejahtera, with you clocking in, checking in to with you checking into all places that you go. So literally there are a lot of data there. So literally they can find out if a person of this age, if he has a free time, how frequently he goes to what sort of trading. Does he go for food? Does he go for movie? Does he go for malls? Does he just do window shopping? How much is their spending capacity? So with the apps, with the informations that we give out, so literally each one of us, like China, each one of us will have a statistics of our own. Or what is your average pastime, average go-to place, how fast you drive your car, how good is your habit, how many tickets do you collect, how many traffic tickets do you collect, what are the crimes that you do. So in if I give you 100, how many percentage of you is a good person? So are you suitable to be selected for a certain position? So this is how mechanically, statistically, our life is revolving. Okay, so this is actually from this small part that we are going to next week, we'll be starting on the calculations and how we begin. So it may look something small, but this is the big picture, but that we are heading towards with whatever that you are going to be exposed to. Okay. Right. So that was data collections and statistics. So one of the most important part of statistics now is data visualization. Because if I give a common man, if I just give them a table of data, it doesn't really mean much. It doesn't tells you much. And you don't know, so what? If you give me an Excel template full of data, I can't see. When I just have a look at it, I won't know what is happening, what is the trend like, I won't know. So I have to put it into a picture. I have to put it into a graph to tell me what is happening. You know what? I'm talking so much, but I didn't record this class. Hi. And nobody told me about it. Okay, never mind. I'll just record it just in case.
Doctor, this class is already recorded in Teams.
Hey, how come? It's auto recording, is it?
No, someone is recording.
Thank you. If someone has done that, thank you. Okay, right. What's scary? That's scary, yeah. What's scary? Yeah, that's scary. Correct. Actually,
the amount of information they can collect.
Exactly. In fact, there's already a video in YouTube which tells you what I'm telling you now, where people are moving, I think in Beijing, people are moving around, and everyone, especially in the trains and all, where you scan yourself in, they immediately get this box of information about you. So this is your world. Actually, I've done half of my life, so I've got another half to go, but you have another almost 80% to go. And yeah, you guys are millenniums, so I think you will get used to it. Okay. All right. So this is the data visualization, and this is mostly what you did in your school. Okay. This you have seen this frequency distribution. In our class, you will learn how to come up with this class. Okay. All this while you've been given this class, and you just do this tallies, and then you get the frequency. But we will learn how to come up with the class, which is the right class, and which data should be given classes. And if you give class, it is a continuous data. And if you don't give class, it's a discrete data. That means the data stands on its own. Okay. The trends in visualization, we want to make, that's actually a skill as well. And in fact, as um, as a undergrad who's soon to be going into the working world, if you grab onto this visualization skill, is also important. It's also a boost for you to actually land a job, because this is something what people who already have a business now, they might not be as good. And this is actually the skills, and in fact this is I should say advantage of the younger generations, because you people are born with all these keyboards, this working with these electronic gadgets. So how you visualize something, this is also critical thinking. You just don't follow people, but how creative you give things will actually attract people to buy your information, to buy your idea. If I am trying to say the product that I'm selling is good, how I visualize it, how I present it to people, if people buy it, that means my marketing is successful. Okay, so this is another skill for you to pick up on. So getting data is no more a challenge. Last time in the like early industrial era, we were all busy collecting data. We were coming up with sensors, we were coming up with apps, we were trying to get information. But now information is everywhere. You just have to get your data, ensure it is a quality data, and then you give a quality data visualization. And that is the power. So you can see during our COVID situation, most of our information was spread using infographics. And in fact, infographic is one of your competition in NACES as well. So that's how important visual is as compared to our writings and our Excel. Okay, so this is how some of you already know all these all these graphs. Okay, this is actually a pie chart. This is a pie chart. Okay, this is a bar graph. There's also a bar graph. This is a line graph. This is a bar graph. Okay, so these are pretty new. Okay, this is a circuit graph. This is a pyramid graph. This is also this is also something common. But you see how the normal pie chart you have seen have evolved. See how interesting things have get. And this is just the simple ones that I'm showing you. And I'm pretty sure you have been exposed to much more advanced visualization. So let me just show you some. Today I'll be doing a lot more talking, but then after this I'll involve you you'll be giving me the inputs as well. Okay. So you see how it helps us to make important decisions. So if we make our calculations to continue renting or to buy a condo, so if you're buying, you probably spending a lot initially, but along the way, in total years, you own the condo and you only spend that much for your condo. But for rental, it may seem cheap now, but after 4 years, it's already exceeding your condo payment value. So it allows you to make life-changing decisions, important decisions. Buying house is an important decision. Okay, this is some sort of decision that you can make after you finish uni and then you're getting into work. When is the right time for me to buy a house, or should I continue renting? When is the right time for me to get married? So you make these decisions. And of course, if you pick up on these skills, you can also learn about investments and trading. Okay, so we use statistics, we use prediction, we use machine learning for for trading. Okay, right, and then let me show you some interesting graphs. Yeah, this kind of graphs where we can immediately see. So instead of just giving a normal pie chart, so I just give you how many, even if I don't read this percentage, just by looking at the length of the color, I know what people want, what people can, or while confident, okay, what they are confident at doing. So you see how helpful the visualization is. And then you have colors. So when I see this, I would remember this. Oh, the dark green was like this shape. I probably just remember this. Some people can remember numbers. Some people remember colors. Some people remember the shape of it. Okay, so see how it gives a broader coverage. More people can actually absorb this information easily. Okay, so literally agree is almost, see, almost the same percentage. Is 85, 80, 75, almost. So just in one go, I know about 80, between 75 to 85 is in an agree category. So we only have about 20, less than 25 who don't agree. See, so and then we have this kind of information, this kind of graph where see how average family income and how they spend on it. So certain years we spend a lot of food, but see as we hit the millennium, higher percentage is going for housing and clothing. Sorry, clothing is lesser. Okay, clothing gets lesser, food gets lesser. Is actually the housing that is actually draining a lot of our income. Okay, so direct information. So of course we have a lot more like this. This is something new as well. I forgot this name. They call it some. There's a name for this field in visual something. Okay, and then this one. I found this very interesting. Okay, this is how popular is your birth date. If I get the time, probably I'll do it next week. How popular is your birthday? So they just took 2 decades of American birthdays, averaged by month and day. So they averaged it, and then for daily, they want to see how many people have the same birthday, and the darker ones has higher number. Okay, so that was interesting for you to see that most babies are born in July, August, September. Okay. And then, okay, these are showing past, present, and future. So how the eclipse path. Okay, this may be not very related to us. Maybe you're not able to relate to it. Okay, this is a wind map. So this is directly drawing the wind and how severe things can be. So this part, you see, you have swirling and high wind capacity compared to these lighter parts. Okay, so I'm sure you've seen a lot of this sort of colorings where they use the world map and give us a lot of information in terms of sizes. Okay, I think I saw this is one. Okay, this is the one I want to show you. So giving you a visualization of 100 brands in value. So just in one look, see this is not something we have learned in school, right? This is a trend in visualization. We want to show how big or how much it's earning. So I don't even have to see the number. When I see the color, that means these are the big earning ones. Okay, I think the color is representing something. Okay, the color is about technology. So just in one look, you can see technology, how in fact, this one is quite interesting. In fact, they even clustered, they clustered the type of it as well. Yeah, this is a lot of work. This, if I'm not mistaken, this is probably done using Python. Yeah, you can use Python to do this. See, they clustered the technologies and then how big they are. And obviously, technology is leading now. Okay, people like us still supporting Walt Disney, yeah? Okay, so this is where your creative thinking is important. Okay, so the link is there, so you can have a look. This was another interesting one on how long and how tall the dinosaurs are. So you could have just done it with a line, but see, someone has thought about drawing it out just to make it interesting and easy for people to consume. So even a young children will be able to get information from here. So they know this is how big human is, and this is how big Titanosaurus is, Titanosaurus. And this one is, oh my God, should I read this? Never mind. Amphicoleus fragilismus. How come? Why they don't have the dinosaur name for it? Usually there's a dinosaur name and a species name to it, right? So, wow, it can go that long and that high. Oh, that's pretty high. Okay, so I think I've dwelt a little longer than I thought into this area. Let's get back to the slides. Okay, so that's my idea of wanting to share with you how important data visualization is. So in your case, I'm also going to get you to do more interesting. I will teach you what are the normal ones, but I want you to do more interesting data visualization. Okay. Okay, most of it is its wordings because it's actually just information for you to read, but I will have some exercise for you to do. Okay, I've got something for you to read and I want to hear it from you on what you understand from here. Can you guys read this? Sorry, can you read this slide? Is it big enough? Yes? No?
Yes,
Yes,
Doctor.
yes.
Okay, great. So
Yes.
I'll leave it big. I just want to see if I have any. Okay. When I'm presenting, I'm sure you're aware that I cannot see your message, right? So I need some voice affirmation. Okay, just have a read. Then I have a question for you on what you understand about it. I'll probably randomly call someone to tell me what you understand. 3 minutes, maybe? Okay, I think you've read. Can I ask, can somebody, you can either type or otherwise I'll have to call your name. What do you understand from this slide? From what I've been talking all this while, what do you understand about the story? What is your take home? Either
The
type
data
or,
that you,
sorry?
the data that you have might not be representative of the true data set. Like there might be lots of unknowns that you're not really taking into account into your conclusion.
Correct. Correct. Okay, it's not exactly just what you see. You should also look into what is hidden among the data. Okay, all right. Thank you, Harsh. Um, anyone else? Come on, say something. Sivagami.
Hello, doctor.
Hi, Sivagami. Did you read?
Yeah,
Okay. So what do you
about
understand from the story?
about the first paragraph, I understand uh, a aircraft team and a mathematician have different knowledge and view.
Mm.
Maybe they don't how to say, the aircraft team not more to statistical knowledge, so the mathematician have that knowledge and experience to see in a different way. And the second one is they asking why this thing all happening is one of the solution could be if we are more apply our statistical knowledge, so we can solve the problem. The way to solve the problem is much easier because we can identify, for example, like which country have more rape case or which district have more rape case. So maybe the concept to solve the problem is more towards statistic knowledge. That's what I understand.
Very good. Very good. See, that's why when you see it from a military point of view and you see it from a statistical point of view, you are seeing it two different angles to it. Okay, so for you as a young engineer to be, unfortunately, you cannot just look at it as a chemical engineer. You have to have your statistical brains as well for you to define the problem that you have in hand. Okay, so we can't just leave it to the statistician, but you have to have that skills in you to see the problem differently. Okay, so in terms of the extra information, actually the story was only about the ship and then sorry, the aircraft, and then the people, there's some other people who give you more information about other situations where the same critical thinking should apply. So when rape cases are increasing, it's not just because it's increasing. It's because, so we cannot address the problem saying that it's increasing now, so something is wrong with people now. No, it's because people are more brave to come forward and report it. So that means the good thing is actually to enforce people to be braver and give them the support to come forward to report it in order to address the issue. Okay, so if we talk about mental illness, it's increasing, or maybe people would say, oh, it's the kind of food, it's the kind of entertainment, it's because of MCO, it's improving. No, maybe not, maybe it's not that. It's maybe because more, we have more treatment now to it. We have more avenues where people can get help. People can go for psychological treatment, people can get assistance to it. Last time people don't do it. Either if we are embarrassed, when someone goes cuckoo, if the family is embarrassed of them, they either kill them or they either keep them, lock them away in a room and nobody gets to see them, so you don't get to see that it is actually present. And the most prominent one is this, nowadays a lot of children, young children, are being diagnosed with this autism, ADHD, hyperactive. See, now they are being diagnosed. It doesn't mean last time it wasn't there. It doesn't mean last time there was no autism. Maybe one of us, not one, like my batch. I've been I mean, like in the last a few decades, I'm sure there was these issues, but you don't see any growth in the reporting of it, because you don't see it. We don't even detect it. But now we are able to. So now we have a data, but that doesn't mean it's increasing now. Now we are able to detect it. So we still have to address this, the root cause to it. Okay. Now this ADH, we cannot address it. We can actually help and assist the students. So nowadays, if you see this, child care, right? Child care places, right? There are a lot of places, they have two division. They can have, they have one for normal children, one to assist children with these issues. These children, it's not a disease, it's just how they see things differently. So when you feed them information, when you feed them knowledge suitable to them, they also learn. They're not stupid. They're not people who cannot learn things. It's just that they learn differently. So a lot of childcare institutions has this, and they cater to it. Okay, so this is how we solve real life problems. Okay, that's good. All right, maybe I move on, and I still have more questions to ask. Right, limitation of statistics. Actually, I've already informed this, I mentioned this to you. Your statistical information is only as good as your data is. Okay, so it doesn't deal with individual items. You don't use one data to use it. And then it deals only with quantitatively expressed items. So unfortunately, all statistics need some quantitative expression. So you can ask me, if they use quantitative expression, how do we do image analysis? Like this in machine learning and all, right? It's still statistics. They can do image detection. They can detect your face. Your Facebook can detect your face to tag. If you're walking around on the roads, your face can be detected as well. Or you can detect certain colors. You can detect on productions. Okay, which fruit has been ripe enough for us to collect, which is not. How do we do that? So that colors, okay, that colors are also transformed into numbers. Okay, the colors has got numbers, it has got ranges. It's actually 256, they call it. There's a ranges to it. So the color, in which spectrum is it? From 0 is white. Okay, from 0 to 256, what is the range of the color? So based on that, the colors, the image, the face, everything is actually transformed into numbers. So you only deal with quantitative numbers. Then the results are not universally true. Okay, what does this mean? If let's say I collect sample, and then I need to do survey. Okay, then I need survey, and I'm lazy to go and look for people. So I ask my parents, my siblings, then I ask my family members, then I ask my neighbors. I just ask people around me. I just ask my friends, people who are like me. So I need 50 people to answer. I just get my friends, my people, my neighbors, everyone who's around me, who's like-minded like me, who uses about the same kind of products that I do, and I take an analysis of them. Okay, if I do that, it's bias. It's not representative of, let's say, the whole territory that I'm living in. Okay, if I talk about, I can talk about housing area, I can talk about maybe district. Okay, so if I collect that 50 samples, it's not representative of the whole the district that I'm living in. Okay, it's called convenience sampling. So this is my convenience sampling, and it only represents this people of mine. So if I want to take a survey of if my product is good selling among people, randomly selected people, it's not. It's only among people who are close to me, so they want to buy it from me, so they buy it from me. Okay, so it may not be universally true. Okay, so we have to do random sampling. We have to take it from a lot of people outside. We cannot just do convenience sampling from our own friends. There are some work that you can do just convenience sampling. Okay, and then your statistics are liable and responsible, but it can also be misused. Okay, there are lots of misused statistics. There are a lot of data. Okay, for example, for the same example that I just gave you just now, I just do sampling. I just collect a survey from my friends, my people, and then I want to show that my product is very good, people are buying, people like to use it, blah blah blah. But the samples are just my people, my friends, who only will be telling me good informations or good news, or maybe I influence them to give me a good review. Okay, so then that I'm misusing it, and I'm reflecting it to others. See, 50 people have used it, 50 people is giving me this good review. That means my product is very good. So I can misuse it also. So I'm sure you can see this in this Shopee, Lazada. See, there was one Chinese website. I wanted to buy things and I looked for the review. She had 10,000 reviews. But when I looked back, there were a lot of people actually gave them 1 or 2 stars. Okay, that means there were a lot of bad reviews for them. The bad reviews were maybe about, like, maybe let's say about 30 or 40 of it. Okay, just 2 figures, but they have 10,000 reviews. So 40 out of 10,000 will give them a percentage of almost 99% good reviews. Okay, so these good reviews can also be their spam, computer spam. Okay, so this good reviews doesn't have as many information as the bad reviews. The bad reviews details out what is there and what is not there. The good reviews are like, okay, good, yes, or nothing. They just give 5 star, 5 star, 5 star. So people can play around with statistics to make things look good. Okay, so if you are in the shopping platform, so obviously when there's too many, you still have to read through to see how reliable the statistics are that is being presented to you. Okay, so this is statistics and the world of it, the big world of it. Okay. Okay, now we're at 10:30. I want to do, I think I want to stop some stories. I want to let you do the reading. So I will move into some exercise. Okay, right. My next slide was about to ask you to tell me where do we use statistics, what is our use and all. Maybe I can do that for another 1 or 2 minutes. And I have some examples of where do we use it. Yeah, maybe I can get 1 or 2 of you to talk to me. Where do you think, 2, maybe 3, we use statistics? Where is statistics important? Anyone? Harsh and Sivagami has spoken just now. Maybe someone else? Before we move into some hands-on exercise, and then I'll end the class. So where do we use statistics? From your viewpoint. Actually, when I speak, I give you a lot of examples from your viewpoint. It can be an industry, it can be a problem. Yes?
When they have too much of data, like in industries or
Yes.
in IT field.
What do you use it for?
To accumulate all the data and make it simplified view.
Yes. You know, production companies has lots and lots of data. They don't know where to store it. You know, they have their own storage room for them to have these platforms to share, to save their data. Is too many. Okay, so we can use statistics to shrink them and to identify which are important. Okay, right. Anyone else? You can even put it on a chat box. Please be a bit proactive as well. See, I didn't ask you to switch on your camera. At least you should show me that you are there listening, giving me some input. Type message. Cheryl Sin Pei N. How do I call you? Cheryl?
Cheryl.
Cheryl.
Yes,
Cheryl.
Doctor.
Yes, Cheryl. Where do you find?
I think statistic is when you want to give a clearer picture to others when you are analyzing a data. So for example, you are doing something, but then you impossible you present all the thing. So you want to present in a simple way. So you use statistic to summarize of the things that you do, the data you collect. That's all for me. Yeah.
Any specific industries that you can think of? You can Give me example. Any industries, anything. Which work you're talking about?
Which work in the maybe manufacturing industry. You manufacture something, then you want to test that during that point your product how, so you use statistics to present your data.
Yes, thank you very much. Thank you.
Okay.
All right.
Thank you.
All right. Okay, thank you guys. So I see some message. Okay, this is good. Okay, social media algorithms, correct. You can see how social media has advanced, isn't it? Yeah, okay, a lot of things. You go to Google, you search for something, but when you come to Facebook, there's suggestions of advertisement for that particular thing that you were looking for, and then it keep popping up right before your face until you buy it. Okay, and recently actually I put something in the shopping cart and then I changed my mind, but that particular Facebook page, it keep popping and asking me on Facebook. This was on Facebook, not on Google. So that page keep popping up and say there's things in your cart and complete buying it. Okay, this was on Facebook. These are improvements. So to see trends of the response from customers, yes, especially on the sales point of view. Statistics often used in marketing, especially to know how well their product or company is doing, correct? Okay. Data science, yes, there's the whole world to it. So data science is a too short word to describe the whole world to it. Shop using statistics to see what kind of customers buying. So most of it, see, statistics of people getting vaccinated, yes, very recent, Fatin, very good. Cryptocurrency, yes, if you are already playing what is the, okay, so you have some reactions, huh? So cryptocurrency, yes, so if someone invested it during the MCO and then you made it, I believe you made a lot by now. Okay, football, yes, football is for you to predict, yeah, what can happen from yeah, football, and then predict natural disaster that can happen. Yes, these are the applications of our statistics. Okay, good. So this shows me that you at least got what I'm explaining it to you, and I can see that you are thinking further from just the simple things that statistics is all about. Okay, that's good. Right, thank you. All right, so I have some applications here which I think you're aware of. So you can just have a read. And again, this is just an exposure for you. And a lot of our work will be something to do with experimental analysis. Okay. Okay, these are all examples. Huh? I'm not skipping. These are just applications, areas of statistics. Okay. Right, there are two main branches of statistics. So we have descriptive statistics and we have inferential statistics. So even by the name you can see, descript means it just describes. Inferential means it is making a conclusion of the whole population based on the small information based on your sample analysis. That's inferential. Okay, so let's look into a descriptive example. Okay, so it is actually describes the nature or characteristics of the observed data. It's always just about the data, but not making any conclusion or generalization. You're not generalizing it. Okay, so for example, let's say I say this class, this skill statistics of mine, the average age of the students are 21. That's it. I'm not trying to say that every single, I'm not trying to generalize this whole thing. I just give an average. Okay, so it doesn't mean that is your characteristics. It's just that from the data, this is what average. So for the daily average of temperature is 25 degrees last week. That's all. Maximum coffee exported in the 20 years, the maximum amount exported was in 2004. The average age of athletes participated is 25 years. Then 75% of the instructors of the AA University are male. The scores of 50 students in a mathematics is between 20 to 90. So we just give information of the data that is available. We don't make conclusion. Whereas for inferential, Okay, the area of inferential statistics entirely needs the whole aim to give reasonable estimates of unknown population parameters. That means you sample a small amount out and then we want to estimate the parameter of the whole population. Okay, that means we make a conclusion about it. This is the example of it. So I made an analysis. The analysis of the income of 1,000 randomly selected citizens is suggesting the average of the monthly income of a citizen is 600. Meaning, in Ethiopia, I selected 1,000 people. I did an analysis and it is suggesting to me that each citizen's average is 600. So this is my analysis and then I am making a conclusion that average income of each citizen is 600. Okay. So we are trying to make a generalization by taking to represent the whole income of the entire Ethiopia by a sample of 1,000 citizens. Based on the trend analysis on the past observation data, the average exchange rate for a dollar is expected to be 18 dirham in the coming month. So from the past observation, they made analysis and they are predicting the next month I'm going to get 18 dirham. So then you are making a conclusion for the future based on the past data. Then you're making an inferential statistics. Okay. So based on the survey, the population of 2020 Ethiopia in 2020 will be this much. So we are declaring an outcome. Okay, so that's how it goes. So when from one information we are generalizing it for a bigger population. For a population means big, so for the population, then that's inferential. Okay, so I've got a quick exercise here. You can just you have a look and you see which is descriptive and which is inferential. I'll give you an answer. I give you probably about 5 minutes. Just use because you have to decide which is descriptive and which is inferential. 5 minutes. I'll just mute myself first. Okay, we only have about 15 minutes. Maybe we quickly discuss what the answers could be. So, other than that, do I have more exercises? No. Okay. Right. Okay. Let's see. What do you think is the answer for number 1? Maybe you can put it on the chat box. Maybe you can speak up. Give me an answer. The manager of quality control declares the outcome of its survey as the average lifespan of the imported light bulbs is 3,000 hours. So is he giving you a descriptive or inferential statistics?
Inferential.
Very good. Very good. Who's that? Who was that?
Me, doctor.
Who's the me? I can't see.
It's okay.
It's okay. Okay, thank you. All right, it's okay if I don't see, but I will, the next time I'll catch your name. So yes, it's inferential. Huh? Why it's inferential? Because it was ikhlas,
Is it
was it just
because
now?
no, not me. Is it because it's using the results of the outcome of the survey
And
to
yes,
to generalize the whole?
Correct. Okay, correct. Okay, that's the concept. So he's using his survey outcome and he is generalizing it for the all imported light bulbs. So if you're buying a light bulb, he's telling you you have an average lifespan of 3,000 hours. Okay, right. Number 2, of all the patients taking the drug, at a local health center, 80% of them suffer from side effect developed. So what is the answer? Is it descriptive or inferential?
Descriptive.
Okay, why descriptive? Anyone can answer why descriptive? Or does anyone thinks it's inferential?
I say it's descriptive because it's just saying that 80% of them suffering.
But we are talking about all the patients. That means we are saying of all the patients taking the drug at a local center. That means everyone who takes the drug at the local center, they included everyone. And they say 80% of them are suffering from side effects.
So it's like saying if you go to a local drug center, you have 80% chance of suffering from side effect.
Yes.
Oh, okay, all right.
You get it? Because we're talking about everyone. See, the whole idea is you take a sample and then you give an output of a sample, then we are being descriptive. But if we are talking about the whole population of all the patients taking the drugs, that means they're saying of everyone taking the drugs, 80% of them suffer from the side effects developed. So is this descriptive or inferential? Descriptive or inferential?
Inferential.
Inferential. Okay, right. See, they give you number 3. We do the comparison. Number 3, yeah. Number 3, the average score of all the students taking the exam is found to be 72. Descriptive, inferential.
Descriptive.
Inferential.
Okay, why descriptive? Why inferential?
I think because it's generalizing all students again.
Okay, so there's two parts to it. It says, okay, what about the descriptive people? What do you think is descriptive?
Because it just say the average of the students. Yeah, so just maybe just descriptive.
But it says the average score of all the students taking the exam is found to be 72. That means everyone, we already include everyone, and the average is 72. So are we saying everyone, we have included everyone, and then the average is 72? Okay, so this is a bit tricky, right? The second one is definitely an inferential, okay, because we're already giving an overview of all the patients. But the third one, it's also giving us an overview of all the students taking exam, and then it's found to be 72. But they're not making any inferential claims. They just say the average score for all the students is 72. But since they're actually generalizing, they took all students, and then it looks like descriptive, but because it's all the students, it looks like it's inferential, because it means all students have taken the exam and their average is 72. Okay, now we're going to decide whether it's going to be descriptive or inferential. We're going to do it together. Okay, that's why I actually looked here. Actually, I don't have an answer, so it's also based on what we see here. So for descriptive, describes the nature or characteristics of the observed data without making conclusion or generalization. We didn't make any conclusion. Designed to collect blah blah without attempting to conclude anything that goes beyond the data. Okay. And then, so most of it, so there's one for students. They say the scores of 50 students in the exam are for this range. So they didn't say all, but they just say 50 students, and then they give a range. And then the average age of athletes participated in London Marathon was 25 years. So this is very similar to what we did. They just say, this is talking about everyone also. The average age of athletes participated in London was 25 years. Okay. And they were not making any other claims. And here the inferential statistic entirely needs the whole aim to give reasonable estimate of unknown population parameters. So this should draw a conclusion. Okay, so back to our question. Number 2 gave us a conclusion that 80% of them suffer from side effects. But number 3, the average score of all students is found to be 72. That's it. So, which one do you think it is? Which one? Descriptive, inferential?
I'm leaning more towards descriptive now.
Okay. Any others? Anyone who still thinks it's inferential? Any others? Okay. So this one sounds, this one is descriptive from what we have seen, and it's just giving a survey found to be 72. That's it. There's no information, any other information that is being given now. Either they passed, they failed, they did well, they did poorly, nothing. I just calculated it to be 72. That's it. Okay, so this is descriptive. Okay, so right. So there's only 5 minutes more to be 11. So I let you, I leave you to decide on the others. Okay. I've done my, okay, or actually I can quickly finish this as well. So number 4 is, what's the answer for number 4? What do you think number 4 is?
Inferential.
Inferential.
Correct, inferential, because you use the 30-year survey and you give a generalization. Number 5 is also
Inferential.
inferential, because you use 30-year survey and you generalize for 2015. Number 6. Number 6.
Inferential.
Inferential.
Yes, because
Inferential.
from last year, yeah, we are expecting 30,000. Number 7. Number 7.
Descriptive.
Descriptive. Because
Descriptive.
yes, last 20 years, the maximum number of 1993. That's it. There's no other information for you there. 20. Sorry, number 8.
Inferential.
Inferential.
Yes, because from the 20-year survey, they are saying per year we are getting an average of 3,000. Okay, number 9, the maximum difference of salary until number 9 is
Descriptive.
Descriptive.
correct. Yes. Okay, so these are the difference. So when you're getting an information, then you're making an inference. All right. Okay, good. So that's it. So I have got some information about the difference on data scientist, analyst, and data engineer. So you can have a read. Maybe in next class, I can just quickly run through this, maybe about 10 minutes. And I have some terms here on quantitative and qualitative data. I think I'll go through this quickly in the next class. So not to worry. Then we will do some more exercise in the next class. Okay, so that's all for today. So what I'll do, I'll take your, allow me to take your attendance again, just in case if I miss anyone. So there's 60 of you. Okay, I got one file downloaded. Okay. Right, I got your attendance. Okay, that's all for today. Thank you very much. So I see you next week. I'll let you know. I think 9 should be okay. Today I made it 9:15 because of I know the incomings and might be having some issues. So we probably start at 9 next class. Right. See you then. Bye.
All right. Thank you very much, Doctor.
Doctor.
Thank you, Doctor.
Thank you.